Okay, so this portion, I need you to think a little bit. Well, imagine a person, and there's one person that made the experiment here. What experiment? Three groups of particle physicists. Okay, fine. This really doesn't matter for this class, but particles, whatever. Why don't we just get rid of that for a minute? Well, that's not necessary information. Kind of it's information, but imagine this experiment over here was made in the US. This was the experiment that they made in the US and they got that result. This was made in Korea and then they got that result. This was made in India and that's what the result they got. And you want to use all three of them. How do you do so? Well, first I would look at this one because this shows the error of all of them. And what does that actually entail me? This just basically says that 1 divided by error, which is the 1.4, and then square. So 1 divided by 1 divided by 1.4 squared, and then 1 divided by 2.5 squared. Okay, we got that. So what does this one mean then? Well, x wave over here um, means, well, what if I did not have that x over here, I would have something like this, right? Which will cancel each other out. Now, this is not really, there's a more mathematical reason for this. If we add x over here, that is how I imagine it. We are adding to it. We're adding a little bit of that to it to like see which one is more valuable and just crushing it into that piece. Um, and I'm imagining that this 1 over 2 equals 1, therefore that's fine. That's how I imagine this to work because otherwise I'm really confused and that it's no help to anyone. Even though that's not mathematically correct, probably. That's how I imagine it. And I get this. Okay? It makes sense to me. And then obviously this part is easy, just getting air. Although it's kind of confusing, but because why is it like flipped? But I imagine it like this. I have this. I actually it's not flipped. I get 2 and this equals 2 over here because I flipped it here. So I actually get the original value over here. Just there. So I don't know why they do this. I'm pretty sure mathematically that's the only way you get the right answer. Which cool. I assume it has to do with the property of these two that no these two that force this to happen. But that's how you do it. Now this is optional. Optional, like the many question I said earlier in the previous part one, part two, that they were optional. Well, I brought in this thing because it's easier to just write a paper. As you can see, I crossed this out because this is wrong over here. What I did there was stupidly say that this is 10.7 plus or minus this, which is completely a no. The reason for that is that standard deviation doesn't mean uncertainty. Standard deviation does not mean that's uncertain. That's one of the key points I learned while doing all the homeworks again. Uncertainty is not standard deviation. Uncertainty is not standard deviation. That point is important. And I realized that while doing all this homework that SD doesn't always mean uncertainty of something. Get that into your head. Luckily, it's optional, so I didn't get any points lost. Next, we have this. It's the pain in the ass. Over here, we get the t-value. Then, because we're asked to get this part over here, because statistics. You know what? I'm starting to love my statistics high school professor. IT high school teacher because I actually know what the shit I'm doing with these statistic numbers. Anyway, t-value, yay, over here we have this over here, which how do I get that? So if I do this, I actually get only 0.03, which is completely insane because that means any number, because 0.5 is like half of this, which is completely irrational. But the secret is this over here, n. N makes it so that the number of tries you have, it multiply it. So to reject it, you need this thing over here. If it's 0. By the way, 0.5 is made by this famous guy and has no mathematical basis for being there. You just have to assume 5 because that's what this guy decided. It could have been 2, it could have been 3, it could have been 4. Um, it's just that this guy decided to just leave it as 0. 0.5. Oh, wait. Sorry. That's not what I meant. This is not. Sorry. I meant to, no, sorry, I said it wrong. So this guy over here chose 0.5 as the reason to reject something. So if it's 0.5 and this is less than 0.5, rejected. Yeah, it's cruel and unusual punishment. But because of that rejection over here, the question asks you to redo the whole thing. So yeah, over here is the answer to that. Got it wrong the first time. Screw that. I got 6 something, 6 7. And then this is how you get this. Screw that. Screw this question. This one. Oh, this one's a cool one. So you're given 3 of these, and let me just let me just clean it up a little bit. The 3 of these, and you're trying to make a line. So over here, you get. Oh, wow! I made a real big mess over here. So this is again. I just wrote it down. Because why would I waste my time on this? So I have this over here, and I plug it. I recommend you don't do this. I only did it this way because I have a what's the word? I have a Desmos, and in the test, we're not allowed to use Desmos. So I recommend you do this individually, and then put it back over here somewhere. Write it down individually. Write it down, and then individually write it down. Each of these big functions, and then if you do that, you realize, and then put it back into the equation because uh, otherwise you're fucked up. You're fucked. You're basically fucked. That's the only way I can describe it. You're basically doomed on this quiz. So you have this over here, and we have this over here. That's due to these equations over here that you're gonna have to actually just memorize, not memorize it. The professor actually gives it because in this day and age, who memorizes? Because you can search online on Google. So if you're doing work, you don't need to memorize. Therefore, what I'm saying is you can basically say that these things are given by the professor, so stop crying your babies out. And then more of this, that's fine. That's just graphing those two. Oh, this is super optional. Do not do this problem because this problem actually sucks and I hate it. Um, yeah, screw this. I should probably cover it. This is from the professor. This is just the answer because I just said I'm not doing this. I screw up. I give up. But what is simply asking, the worst part is it's asking something very simple. If there's only 2 dots in a graph, the line of these two, no matter what they are, will cross these two. Whoa! Well, instead of doing this way, there's actually other way to do it. I just didn't want to do it. Well, you make a fake 2 digits like that. You say that is where we're going. Okay. And we say if you want to be super ambitious, I think they didn't do error, so it's fine. It's fine. So you don't need to do error, but you can do error. You can do weighted if you want, like a psychopath, like a little psychopath. And then you can do um wait n minus 2. I believe it's n minus 2, right? No, no, I don't even remember the. You see, I don't even remember the two equations I needed for this equation. Question, croissant, croissant. Oh, you don't need that. Yeah, yeah, you don't need that. Okay, so the other way is to see this way through, and then choose two random ones, and then get these two. So let me just do this. Let me just select this, and then copy it. And remember this: a equals square root of x squared y minus. I should go slower. I'm trying to look over here and doing this. It's kind of equal n squared minus x squared, and then actually, yes. Oh, no wonder that's why. And then b equals n xy minus x y divided by this. There you have it. Okay. This part is useless, so let me. That part is useless. Um, so these two we have, and then you just plug all that in to here, and you should see a line that's basically the slope of that, and then the intercept of that. We could do it if you want. Oh, this is also optional because according to this, it's more painful than the other one. Yeah, for some reason the teacher has something like this, but I'm pretty sure it's supposed to be something like this because that's what I got, kind of. I must be doing something really wrong, but I couldn't figure it out for the life of me, and it was optional, so I stopped here because I was not about to do something like this again. I mean, look how painful this. This is painful. I am not about to do something like that again. For something so optional, so it's not even going to be on the test. It's optional. Pain in the ass, but somehow the teacher got something like this, which yeah, I'm not about to redo it 20 times to figure some that out, and I somehow got this instead, which I'm good enough with my answer. I'm not gonna try again and try to figure this shit out. So yeah. And then this one, oh yeah, this one is just doing R, just following and plugging and chugging. I'll be honest, I did a sneaky trick. I put this into. This is why you'll take statistics in high school if you really want to. You go to the cell, get R squared, and then you get R squared of 8 something, and then square root that to get 6.92. So you don't actually have to do any of the work, and you know how to fake do it. AKA no, go to your freaking calculate. Go to your freaking no, once again. Google Excel sheet. Go to series and go press a trend line and go to R square information and get a 0 point and then square root it because that literally gets you that. But that's the cool thing because if you know that, you can get square to get the R square, which has a lot of different properties, which is weird and fun to play around. And then you can go to the table. So table C over here. So I feel steel. I think it was 10. Um, I think it was 10, right? I got no way. I lost it. I don't know where it is. Ha ha! No way. All right, no. I know how to do this. I think it was this two. I think it was these two. It doesn't matter if I get it wrong. Yeah, it was those. Oh wait. Uh, so how do you read this? Is 1, 2, 3, 4, 5, 6, 7, 8. 8, and then that should work. 8 over here. Ah, here it is. I don't know if you can see my cursor, but it's these two. You can see these two. And I'm not sure if you can actually see that. Well, I'll see later. Oh, that's how you read it. So you go over here, 6 point something, and then go over here to 8. Well, I'm not sure if you can actually see that. Wonder if I can highlight it. Maybe I should. Well, let's see how if I can change that. No, I can't. Oh well, if I can't see that, I'll just do this then. Save. Save it. And then upload it here. So I can just basically show you now. It's over here, over here, to over here. There, that should be good enough. Because it's 6 point something, so we go over here to over here, and then you get 8 of these, so 8 over here. It's going to over here, and you're done. Good. I think that was good enough. If it's not, then I can redo it later. Here's a fun one. So we know that, okay, so obviously we're expecting a loaded die. Loaded die means a cheat die. So it goes into one side more than the other. And because of this doesn't make any sense, right? How this says 20. So we expect that, and then expected is 4 EF, right? Because it's an even die. And then we know in a distribution like this, that should be like that. We know expected value is 4E, so we can actually say the SS should be a square root of E. So we get this over here to observe expected. Let's see, this is the whole entire rule of, what was he call it? Rule of chi-square, which with the statistics you would know. I don't like high school statistics, as you can see. And then go over here to here, and eventually if you do everything, you get 15.9. Since we spec 6, because if this was a truly even curve, one thing about chi test is that x chi should equal n, because that is what you should expect. And then I got it wrong the first time, haha. I got 10.23. Next over here, optional because it's like really not fun. You get 10.06, and then you get chi-square 10.1 basically. And then D is the 5 over here, so divide by 5 equals 2. And then you use, where was it again? It's a D. And you just have to do 2, and then 5, right? The 8, right? Oh, no. What was this again? 5, 2, which, what? Did I reject this? Don't remember. I just did this, which is, let me check something. That doesn't make any sense to me. Chi squared. Let me check how this works again. I get d5, d5, I think it's 7. And what makes it reject or not reject again? Oh, right. If the assumed distribution is correct, x squared should be an order of 1. Um, yeah, so what's happening is this x thing, even without the table, should have been 1. And if your assumed um, thing was correct, and the assumed thing was a equals 50, and this, so you can do all the math, do it by plugging into here, and you won't get the right answer. I don't really explain how to do it in the diagram, so I guess I should explain. So y equal 50 plus 6x is how you do it. And then you just get each one. So this is 56, this is 212, 62, and so on. And then that equals the function over here. The y observed is over here, and the SD is SD of expected, so XD of this. So we just have to do SD of that to get that, and then you should get this. And then definitely not correct. It is wrong. And with that, I'm done. If you want to know how to do the table, well, this is just going to statistics basically, where the t value is over here, and then the t value is still, and then just go to decimal point and what percentage it is. This graph, this shade there in area is what it looks like. This is the other half, and then this over here is chi test we just used, and then r score I just showed. So as I showed it earlier, I mean. So we're done basically.